A very warm welcome to everyone joining us today. It is indeed an honor to welcome you all to this insightful session of the ATAL Faculty Development Program on Generative AI Techniques, Tools, and Applications. After an engaging 4 days of session, the ATAL FDP on Generative AI, we are delighted to welcome you all to the day fifth of this knowledge enriching journey. Yesterday, we laid the foundation by exploring core concepts and emerging trends in generative AI. Today, we continue with more advanced discussion that will enhance our understanding and practice and practical application of this transformative technology. We are honored to have Dr. Krishna Kummamuru and Dr. Debayan Chakraborty, our esteemed speakers, joining us today to share their expertise. Let me introduce our first speaker, Dr. Krishna Kummamuru, who will be presenting on building Gen AI-based system. Dr. Krishna is an innovation leader with wide experience in AI technologies. He has experience in various aspects of AI innovation development, from identifying the opportunities to designing, building, and deploying the system to realization the business impact. Dr. Krishna, we call him as an alumni of prestigious IISc Bangalore. He is one of the first person in IBM Watson team. His career in artificial intelligence started from 1993, and he has been in the field in academic and industry since then. He is presently responsible for creating portfolio of AI innovations that improve efficiency in delivering BPO services as well as differentiate Accenture's BPO services in the marketplace. In the past, he had contributed key technical innovation to IBM Watson engagement advisor and built IBM Watson based solution for financial and healthcare sectors. He has also led a team in building for AI tools for various technical support roles which were deployed across IBM Global Technology Services. He received several IBM Research Division Award for his work. He has 32 patents granted by USPTO. He authored over 30 publications in refereed conferences and journals with a citation count of about 2,350 as on February 2019. A heartfelt thank Dr. Now I would like to invite Dr. Krishna for enlightening us with your session. Over to you, sir. Hello, sir.
Hey, thank you, Arshi. Can you hear me?
Yes, sir. I can hear you.
Perfect. Wow, it's good to speak in this forum. There's so many people, and it's let me start. So, I think it looks like you had uh, uh, Dr. Anurag, this is a fourth day or second day?
This is the fifth day.
Sir, it's our fifth day.
Oh, this is the fifth day.
Yes, sir. This is fifth day.
Oh, okay, perfect. So I think the participants would have had lot of they would be the participants would have been uh, gone through a lot of material on Gen AI, right?
Yes.
Yeah. So maybe I just want to give some caveat here because it's a very evolving, very fast evolving area, and some of the topics that I'm covering would have been covered before, but maybe because of my background, the way I present could be different from what people have presented before. So please excuse if some of them are repetitive. And so let me start sharing my screen. So um, And let me know once you can see my screen. Can you see my screen?
Yes, sir, it's visible.
Perfect. Oh, 1 second. Oh, perfect. So today I would be talking on building GenAI systems. Basically, this is what I will be covering, right? Some basic introduction and what we can do with Gen AI and some application categories, some challenges on running LLMs on servers, prompting, and what I will not be covering is also important, but just to set the context, right? I will not be covering how we build these LLMs and how we build them, some of these fundamental network architectures like GANs, VAEs, and etc. And I also did not prepare for agentic architectures, even though I have been working very actively in the last couple of months. Uh, we are actually creating agentic based applications very actively, but for the scope of this talk, I will not be covering that. Right, and so let's move, right? I think all of you would be knowing what is Gen AI, right? So basically, if you see this talk, I've used uh, Gen AI tools, right? Basic, so it can help create the content. Of course, yeah, there is a question. Sampath, Varadarajan Sampath, you have a question?
So Krishna, you continue. If someone has question, then they will type in chat box.
Perfect. Okay. Yeah, that would be better. Maybe we will yeah, maybe we can take a break maybe after half an hour or so, and then I will cover those questions, and then we will get back to the talk, right? Okay. Okay. So uh so basically, this is Gen AI is used to generate the content. I think it has the potential to revolutionize many aspects of our lives. As you can see, the way we interact, one of the first things that I can see is the way we interact with the search engines, the way we find the information, and the way we make the decisions, right? Previously, in the previous era, we were using uh, mm, we were using search engines to find the information, but now we are finding information that can help us decide. And I think that is how the search engines are able to understand what we are saying and try to give us that uh, the human like answers, right? So uh, so yeah, so I think all of us know. So there are fundamental principles of building these GenAI techniques, right? Basically, let me tell. I mean, I'm using GenAIs and LLMs interchangeably. As you know, GenAI is a class of AI techniques that use LLMs, I can say, So LLMs are the large language models that are core basic neural network architectures that help in generating the content, right? So to arrive at this, these LLMs that generate, they based on some very fundamental principles. Fundamental principles are variational autoencoders, generative adversarial networks. I'm just quoting them. I did not each one of them to explain as a half an hour or to 1 hour uh, talk, right? I'm not going into the depths, but I just wanted to make mention that these are fundamental architectures that helped evolve to the present LLMs, right? And so here you can see this is how it evolved. Whole LLM architectures started from word to vec, very basic word to vec. It started with how do we represent, how do we have a vector representation of text, right? So that's how it started. And then you had autoencoders and encoders and decoders and decoders only. So you can see all the GPT-4s and GPT-4 and Claude, all of them are based on the decoder only architecture. And this is as of 2023. And now in 2024, of course, these are another, all these things are copy and paste from some sources. The source is also given here. So in 2024, we have this consolidation of, I mean, you have open source models and you have closed models like Gemini, GPT, and Claude. And you have open source. I think you have in the open source, you can also add Mixtral and DeepSeek, some part of DeepSeek that come. That also, of course, some of them have their closed uh, versions as well, right? And this thing is uh, this thing is so active, and so many people are working on daily basis. You keep seeing a lot of releases. This is, for example, in 2023, this is how it has evolved. Even as of 2025, right? You can see that DeepSeek, and even after DeepSeek, there are quite a few other. Last week, if I remember correctly, I've seen some tweets about mimicking DeepSeek with still cheaper way of building these DeepSeek kind of models. Okay, so that's all I'll be talking about. Some fundamentals of LLMs, not much. We will revisit this again after looking at some applications of GenAI. Okay, so I would pause here and ask if you have any questions. Okay, so let's move on. Okay, right. So what are the applications of GenAI? So this used to be the initial page of Gemini few months back, right? You can understand, create, and explore whatever you want to do, right? Or this thing is initial screen of Bard. Bard was the earlier version of Gemini. Okay. So basically, if you look at it, so these are various applications that are possible. These are right. And the application that you can build is only, I mean, your imagination is only the restriction. I mean, you can do almost a lot of stuff with this GenAI model, right? On the text, you start with summarization, translation, generation, classification, all those things. Now, previously we used to build, I'm assuming that the audience know some audience have some background on machine learning and deep learning, at least machine learning, some concepts of AI and machine learning, right? So all of you would be knowing what, how classifiers, for example, how classifiers are built, how question answers are built before LLMs, right? How sentiment analysis is built. So they're built based on specific uh, training data, and we used to train individual neural nets kind of models, right? Now, even NER, named entity recognition, all of them, there it used to be where each and every problem used to be a task by itself. Now, most of these things can be done through just prompting. The LLMs are really large and they're very generic and they can do almost everything that you can think about. And they become multimodal, right? Not just the text. They can also understand the images, generate the images, do all that restoration, image to image translation. They can create new images. Actually, we have this marketing operations business where, I mean, I think this is more applicable in marketing, right? Where you can create text, you can create images, you can also create audio, videos. Instead of spending on too much on agencies that create these artifacts, right? Either images or videos or audios. So you can use the Gen AI to create. I mean, you just tell, explain, you just rather what I was saying, you just describe what you want to generate and it will generate that for you, right? So, and then the same techniques you can use for, of course, generation is the uh, uh, main strength, but you can use that for other tasks as well, right? So how these different applications are built using GenAI techniques, right? So there are some very uh, popular architectures, right? So, archetypes, I should say, not architectures. They are archetypes, right? Application archetypes. One is simple prompting. I'm sure all of you would be knowing what is simple prompting, but I'll try to give. We will try to go to slightly more details of what is a prompting and how we can actually use this prompting to build applications, formal applications, right? And it can be used as a natural language interface to data. For example, we can ask questions in natural language instead of writing your own SQLs and all that. You can just ask in natural language, it will give the answers. And the third one is, these are some, right? These are some archetypes. There could be many other. Uh, so so first two are, if you use generic uh, LLMs, then you can do first two, right? The moment you want to use those LLMs specific to a domain, for example, you want to do a Q&A for question and answering on legal specific to okay, say consumer uh, grievance in India. Suppose you want to do a question answering on that, right? How do you do that? So these LLMs can answer everything, but can they answer effectively the consumer grievance in India, where the laws are changing laws may be changing in some frequency, right? These LLMs are built where they are very generic. So to do that, we can use RAG or fine tuning, right? RAG is the retrieval augmented generation that I'll just briefly describe in this talk. Then you have fine tuning. And then if you want to build these LLMs from scratch, there are some techniques. Of course, this is a very costly operation. You need to have a lot of data and you need to have a lot of compute. But if you have all that, you can also build LLMs from scratch, right? So some of these archetypes I'll go into details, right? And let's go, right? What is, yeah, so simple prompting. These are some of the examples, right? So you can get, I mean, should I just show you a couple of these, how these things work? Maybe I'll just show, right? Just give me a minute. Let me just bring up my uh I just want to ask, can you see my screen?
Yes, sir.
Yeah, perfect. Perfect. So 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 we can ask a couple of these questions, right? So uh, in NCR, let's say, or Delhi, right? And you see that you ask the same questions. Wow, it, it came about Krishna furniture. Okay, so you see that this is just a prompting. You can actually use, this is actually talking about this particular question is we are asking a live thing, right? This particular question, you need a live. It's not a general knowledge question, right? This is a generic question. So general knowledge question also you can build an application on just health advisors, right? So this is very simple prompting strategy, right? You can do this simple prompting, and but there are different types of simple prompting techniques that one can use, right? So right. So what simple prompting the applications that you can build is is like you have an application server where you give uh, I'll come to more details on it, but for example, you want to like just dial, right? It tells all the suppliers, right? You can make your application very specific to a procurement domain or a healthcare or a legal, where you can ask any question, it will translate that question and send it to LLM and it gets the answer and you'll give it, right? The way you can make this thing then you can ask what is so unique in this. People can directly ask an LLM, right? But what could be unique here is the persona that you can add to the prompt. You can add your own formulas to the thing. Suppose you are a financial advisor, you can give a lot of formulas in this prompt, add that formulas to your questions. Then you can actually calculate and give the answers, appropriate answers, right? You can enrich. We will go to various ways of doing this prompting, but you can enrich the prompt simple questions so that the users would get appropriate answers, right? Okay, so the other one, the other pattern that is doing NL question answering on structured data, right? What you can do is that you can take a query and you add that with the schema of the database, and you would get the SQL query or whatever the query that that DB can support, and that that you perform on the DB and then give the results, right? This is the second pattern. Okay. And the third pattern I was talking about is retrieval augmented generation, right? So what you do is that in here, given a question, first you do this search, a simple search, right? A simple search on these documents, right? Either documents or database tables or whatever. And then you get that context. This is called context. And then you give the query and the relevant content, and you would get the responses from LLM, right? This is examples of this is product support, right? If you ask your microwave, Samsung microwave is frequently getting switched off, right? Or frequently getting heated up, then your LLM may not be knowing specifically about Samsung, uh, uh, microwave with this particular number, right? This version of my Samsung microwave. So maybe those product manuals are troubleshooting things. You can add it in your corpus, and you can do this kind of RAG-based. You can develop RAG-based systems to do a question answering, right? Before I go to the other models of building the GenAI-based systems, let's get to some basics of prompt engineering. Okay. So, so I mean, there are a lot of resources in this, right? But you can go through this, but I'll give you some very at a very high level what kind of prompting, what you should do to get good results, right? In fact, prompt engineering itself is a course. One can do a 3 month or 2 month or 3 month course on prompt engineering. What are various ways of prompting, and what all you can achieve through prompting, right? Simple prompting, right? So these are basic elements of prompting. I'll, if time permits, I'll go into the more details of this prompting. You can give, it should have the following things, right? You should have the instructions, what the task need to be performed. It should give some context, and it should have this input data. the exact data, right? Exact question, and then you can also specify the output indicator. What kind of format? Suppose if you're building an application after this phase, right? You can ask the LLMs to generate the output in JSON, or you can ask LLM to generate the output in CSVs, right? Or see, for example, if you want to show the pie charts or some of these charts, so you can ask LLM to generate in a format that your UI rendering methods can consume, right? Okay, so in this, one more aspects in prompting is the context length, right? You have various LLMs that have different context lengths. I mean, again, this is slightly outdated slide, but you can the point that I want to mention is the context length. The initial, just give me a minute. I- Initial versions of the LLMs have a smaller context window. Basically, the context window is the length of the prompt that you can send. You can almost assume that this proportional. The length here, here whatever I have mentioned is a tokens. Tokens is uh, there is a uh, roughly they're proportional to the number of words in the prompt. Okay, they're not exactly the number of words, but they're proportional to the number of words. But so it shows the number of words that you can send. So if it is, say, for example, if it, let's say, I mean, now this has changed, this has increased quite a bit, right? But in a way, you can put whole textbook in the context length, and you can ask any question.
Excuse me,
Of
sir.
course, yeah,
Sir,
yeah.
want
Go
to
ahead.
ask one question?
Go ahead.
Uh, Sir, actually, I'm
Please,
asking that
if
by
you have question,
giving good prompting.
listen, participant, please. If you have question, type in the chat box. Sir will take break after some time. Then you can discuss those. Otherwise, it will be very tough in between. Okay.
Okay, okay, sir. Okay.
Okay, should I take this question or should we move on and then maybe we'll take question later?
Yeah, at a time we can take all the questions that
Okay,
we
perfect.
have many number of participants online.
Okay, perfect. Sure. Okay, okay, so this is what I was saying. What I'm saying here is that the context length, so you can do lot of I mean the context length is increasing, right? So uh, so context length is increasing. So you have you can actually send whole text, right, to answer a lot of answer the question, to get the questions. And basically you're also charged based on how many tokens you send, and how many tokens you are expecting, right? The charge, the or the whole performance. I mean, there are two things. For closed LLMs, there is a charge, but for open LLMs, where you install on your GPU machines, the time it takes depends on number of tokens that you send and number of tokens it outputs, right? I'll show you why it takes so much time in a minute, but so it takes that much time. So you need to really uh, give a very crisp questions, right? Okay, so that is why putting a question in the right way is very important. Okay, so coming to just some prompting strategies is I'll show you some more prompting strategies, but you have various strategies like zero shot, one shot, few shot, and you can also talk about chain of thought. And there are quite a few such things one can do. So this is a, I mean, I gave some examples here where in zero shot, you just ask English to French translation, whereas in one shot, you give an example and then ask the translation. And in few shot, you give some more examples, not just one example, you give some more examples and ask the question. So as you do this, as you increase more and more, the responses that you get would become better and better if the task is difficult, right? For small tasks, even without any examples, it can work fine, right? Fine. So I'll pause in another in another three slides, right? And then we can ask questions. Uh, so the other one is other important archetype is fine tuning, right? All the LLMs, as I was telling you, all the LLMs are very generic. All the publicly available LLMs are very generic. If you want, say, healthcare or any domain specific LLMs, so you need to do some fine tuning. Basically, that fine tuning means that you need to generate some examples, and then there are ways that you can fine tune these LLMs. You train them. There are various ways of training them, and then you fine tune, right? Basically, you have the data here, training data. You have this LLM. You fine tune. You get the fine tuned LLM. So there are various ways of fine tuning them. So these are a typical LLM would look like. You have various layers, and then you have various layers from input to the output. So one way of fine tuning is you freeze all these layers and you introduce another new layer, and you can train only on this, because mainly because in order to train all of them, you need to have lot of domain specific data, right? So it is kind of this particular, in this case, this particular first 5 layers have the generic knowledge, and you have domain knowledge only ingested in the last layer only, correct? So basically the number of parameters that you would be learning is this much, and that's why the requirement on the number of examples to fine tune this are reduced, right? There is another way. If you have more and more samples, then you can actually unfreeze all the layers and try to learn. But there are ways that this is called low ranking adaptation of adaptation. So there are other ways of training whole network itself. But this thing is done in a slightly intelligent way. So this is what you have, this you freeze, right? You introduce another layer of network which is low in ranking. Basically, to train this, the number of non-zero parameters would be less here, and you learn this particular layer, right? So then this is called LoRa, and there are various versions of this LoRa, and so this is one more way of fine tuning, right? If you want to build LLM from scratch, right? If you can invest so much, There are the present LLMs. This is the typical way the present LLMs are built, right? What you do is you start with just learning the language model. This is a raw input. You take all the text, right? And this is how these many number of GPUs that you need. You just do we just raw text, right? You build the base model. That is called base model, and then you do supervision. And this can be say 100 to 100K responses, right? They can be low quantity, high quality responses. Then you do that. That is a supervised fine tuning, right? And then you can have comparisons, and this is called reward modeling. And finally, you have reinforcement learning, right? Whenever the moment, see, in this model, publicly available models, the moment you give some feedback, right, that would get into the reinforcement learning, and that's how they keep you know uh, uh, improving the performance of the models, right? So this is the typical way of building LLMs from scratch. Okay, so I'll just pause here. If there are any questions, I would take, and then we move on. Is it fine, Dr. Anurag Singh?
Yeah. Now we can take the questions. So if you have question, type in the chat box or raise your hand. So sir, one question is available in chat box.
Okay. Okay, no gradients. Let me just check where that particular thing. Uh, which slide you're talking about? Which slide are you talking about, Bala? Oh, in zero shot, right? Okay, in zero shot. So there is no, the model is not changed. There's no so when you uh, so the model, the LLM backend model is not changed. There are no gradient updates. Whereas in fine tuning, you actually change the values, the weights of the model. Did I answer your question? Yeah, you can say yes. I mean, you can raise your hand and say yes or no, right? Basically, what I meant. Hope you got it, right? Yes. Okay, perfect. So the second question: if we train our model by giving some related data, by giving good prompt, so it might be possible that GPT or other GenAI gives some response to all clients because it shared data with the central server. Is there any technique to protect the data and other data privacy techniques we can apply? Okay. So when you are giving the fact that, for example, let me show you the fact that you like this response, right? If I say if I like this response, this is taking the thing, the fact. So this is what you give the response, right? These are you are giving the response. So this is used by say Google to train this. But if you do not want your questions or anything to be used, I think there must be some setting. It depends on the provider, LLM providers. You can, for example, in our organization, we have an agreement with a couple of these cloud providers, where they cannot use any of our data, whatever we give, right? They cannot use it to improve their models, right? So all of them, uh, so it has to be done at the organization level or at some settings, right? I think if you are using some APIs, APIs should have some settings where you can tell the LLMs not to use this, right? Hope I answered your question. And there are other ways of if you're really bothered about it, then there are ways that you can, for example, in uh, in uh, in talk to data. I mean, when you are answering the question based on structured data, you can you if you need to send some data, then you can actually do some mapping internally. There are some privacy preserving techniques that you can do to hide the real data. But that they're all different techniques, totally different techniques. But in general, at an organization wise, if you do not want your these models, or at the interaction wise, if you do not want these models to use the data that you are using in the prompts, I think there must be some settings or some at the organization level you need to have that that understanding, right? Uh, uh, okay, so for fine tuning, can we have any number of layers? Is it based on the data? Okay, so basically, I'll tell you the uh, uh, there is something called bias and variance, right? Overfitting, right? So if you want to, the principle is very simple. If you are trying to uh, uh, estimate an equation with three variables with two data points, right? That is ill-posed problem, right? You cannot actually do that, right? If you have 2 points, you need to estimate three parameters. You cannot actually estimate, right? One of the parameters could become that's an ill-posed problem, right? You need to have at least a reasonable number of data points to learn a given network, right? So that is why basically if you if you want to learn all these parameters, like there could be 10 billion parameters or 1 billion parameters in this, then you need to have at least, if you go with our traditional ML rule of thumb, right? You need to have, if you are looking for 1 billion parameters to learn, you need to have 10 billion data points, right? Approximately, right? But if you are doing this kind of model, right? You are just learning the first layer or two layers, then the number of parameters that you need to learn from the data is less, right? So the data requirement is less and you can learn, right? Similarly, the same thing occurs here also. The number of parameters that you need to learn should be proportional to, in a way, related to the number of data points that you have. Okay. So Dr. Sugandhi, did I answer your question? Perfect. So can you let me know in uh, uh, due to network issue, I could not log in on time. Okay, fine.
Not a
That's okay.
question.
Okay, that's
Any
not
other
a
question
question.
at this
Any
time?
other question? Yeah. Okay, so let me jump to I'll come to the inferencing part in a bit. Okay, but let me come to uh, prompting, right? Let me just do some little bit of prompting and then I'll go back to that inferencing, right? So chain of thought prompting, I'll give you some examples of the way you can create the prompts. Chain of thought prompting is very popular one. If you give this kind of input, I'll leave a minute for you to read. Maybe I'll let me read it. Roger has 5 tennis balls. He buys 2 more cans of tennis balls. Each can has 3 tennis balls. How many tennis ball does he have now? The answer is 11, right? The cafeteria had 23 apples. They used 20 apples to make lunch and bought 6 more. How many apples do they have? It gave 27, right? So somehow these numerical things it could not answer. But now when I'm generating the answer 11, I'll give some more details, right? This is the answer that I'm expecting. These are the answer that I'm expecting. So I'm telling it to reason out and give me a detailed answer. So when the example is giving more reasoning, then the answer you get is a better answer, right? So this is the chain of thought prompting. So uh, uh, tree of thoughts, and there are other techniques, but this is very important, right? The prompt structure, I'll just very briefly tell you about prompt structures. There are various prompt structures that we can use, right? So I told you that you need to have the input, context, the task, and the output format, right? Initially, so there are various things that you need to explicitly mention in the prompt if you want to get a good answer. Could help develop a content marketing strategy for our new research project. So this is the action part, right? And this is the aim part. We aim to generate interest and increase awareness among our target audience of IT professionals who are passionate about the future of work and tech trends, right? And the third one is the expectation. So you need to specify all these things explicitly if you want to get the answers. So this is APE is one pattern, right? RTF is another pattern. Typically, I tend to use this, of course, based on of course the context. But this thing is a very popular one, and role is the one that you should mention always. I want you to act as an interviewer. I want you to act as a procurement advisor. I want you to act as a health doctor, right? Or I want doctor who is okay. So it could be as specific as this, right? I want you to act as an orthopedic specialized in back problems, right? So you can have this role very specific, and then you can ask what is the task that you want LLM to perform, and then you can give the formats, right? And again, you can give the task, action, and goal, right? There are various ways. So you need to be very precise. The more and more redundant data that you add to the prompt, it would confuse the LLM, right? So there are various ways: role, action, context, and expectation, right? Imagine you are an IT help desk analyst, explain a troubleshooting process and suggest a set of actions. There is a customer who has troubleshooting issue with the slow computer. That's a context. The expected outcome is to select a set of practical, effective tactics to solve this problem quickly with a high level of customer satisfaction. That's an expectation. So these are various, uh, you know, uh, uh, various ways of organizing or structuring your prompt, right? Other things that you need to consider in prompting are what is the cost of APIs, and you need to, of course, the cost of fine tuning, cost of servers, right? And there are a lot of challenges in building LLMs itself. So you need to consider some of them, right? Okay. So let me just go back to the inference part, right? Okay. So let me just show you one graph that Jensen uh, uh, talked about in one of his talks, right? So what happens is that the inferencing training is one part, and inferencing is also very costly. These are it comes to, right? As the number of parameters of the network increases, even inference cost is also increasing, right? You know what? I'm hoping that you know what is the difference between training and inferencing, right? Training is where you are building the LLM. Inferencing is when you are asking questions, and when you are asking questions, and when LLM is responding to your questions. Okay. So, 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 because inferencing is important because training is just one time effort, correct? Whereas inferencing you need to do for every query. So if inferencing will be very costly, then the whole model will become practically not feasible, right? So we need, that is why I'm talking about the inferencing, right? Inferencing is very important. Okay. So how do we so uh, so how do we reduce the inference time, right? Let's look at it, right? So there are two ways to reduce the inference time, right? One is quantization, the other one is effective management, right? Basically, let's look at how the inference happens, right? All of you know that, I'm assuming that you all of you have seen this at least. This is a transformer model. This is the basic architecture which is feeding all our LLMs, right? Where you have position and encoding, and we have this encoder decoder models, right? So let me just show you how typically how uh, output generation, the inferencing happens, right? There are something called K and V vectors matrices that are that are that are generated and they are used. Okay, so this is how it happens. This is how it happens. The first output token, right? In the next output token, this thing is given back here, right? Now the this thing is fixed. Okay, this left hand side part is fixed, and these are the rest of the tokens are. This is the input question, right? And the rest of the questions, the rest of the tokens are generated. So in a way, you are if you look at this, your input, all that context, right? Whatever I'm talking about, I told you that input context length and all that. It is basically, it comes here, it goes here, and then your output starts generating like this, right? You look at this, this is the main part, is how this KV matrices are used in this. So that is the inferencing part. Okay. So basically each of these computations, they are matrix multiplications, right? If it is 32-bit and 32-bit multiplications and additions. So one of the most popular way of reducing this computation is through quantization. You quantize these parameters. Okay. So there are various techniques to do this. Okay. So you can just truncate your 32-bit into 8-bit or 4-bit. What happens is that you can speed up, right? But inference is slow. Inference is slow, but the accuracy is not so accurate. Okay. But there are other these things, GPTQ and AWQ and GGUF. There are other techniques where you can actually get better accuracies. Yeah, Punita, you have some question? There are a couple of questions. You want to ask now, or you want to ask maybe after I cover this? Okay, perfect. Okay, so there are. Let's go through this one. Some of these things, they are very interesting, right? So how do we? What are the ways to you know, increase the inference speed, right? So this is the okay. Let's go through this. So this thing is this is a straight away simple quantization that this is a 32, these are 16-bit, the binary float, all those things. So the this increases, this is simple quantization, right? So the other quantization is the activation aware weight quantization, right? So this is quantized uh, based on the how much the activation is, at this levels, what are the typical activations are, and based on that, it adaptively uh, uh, quantized. There are various other techniques that are still evolving. Right, there is learning aware quantization, where it depends on not all uh, mm, not all weights are updated during the training, uh, and to a same extent. So how the weights are updated during the training, what are the variations of those weights? Based on that, they decide how to quantize those weights, right? So that's called learning aware quantization, and that's one of the new techniques, and that also performs well, right? So the other part that I wanted to talk about is the where you put the memory, correct? Quantization is one. The other part is on the memory management. How do you put the memory and all that stuff? Here are some examples, right? So So let me just, I mean, you can go through some of them, but let me just show you uh, 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 page retention, right? So where where you put these KV matrices that I've showed you before that you use for inferences, that you cache them, that those are the things that you need, right? And that you cache, and when you cache them, then the inference time would change, right? Because you don't need to access the main memory, right? So that is called paged attention, and that's how uh, uh, you you improve the speed of inferencing, right? So we don't need to worry too much on how to code them. They're already existing. Some frameworks are already existing. One is TGI, VLLM. These are old, but there may be new ones that are coming. Basically, I want to highlight various aspects of the inference frameworks, right? So for example, in here, right, VLLM uses AWQ, whereas TGI uses GPT quantization, right? Uh, so VLLM supports, these are publicly available packages. So VLLM supports for every new, LLM that is open source. So even these TGIs and VLLMs also releases their own packages and patches. So, so they are they run very fast, and I mean, when compare, if you don't use them and if you use them, this is how it happens, right? If you use basic thing, the throughput is 6.4. I mean, this is just for Llama 13 billion, uh, right? It is with VLLM, it is 154. VLLM is uh, very effective in inferencing, right? Then before I stop, I just want to show you some NVIDIA stuff, right? Basically, and then I'll take a lot of questions, right? I have just four slides to cover, and then I stop, and then I'll take questions later. So NVIDIA has these how this stack is, right? This is basically for very fast uh, inferencing, right? You have basically that device, the GPU driver that is called CUDA. And then on top of it, you have this Kubernetes thing. And within that NIMS, the NVIDIA has a thing called NIM. Within that NIM, you have various that NIM provides uh, 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 various modules to optimize these tasks, right? For finding, for video processing, they have some techniques. For just data analysis, and they have uh, they have some things for memory optimization and all that, right? These are all that NIM has these modules, right? Uh, they have also have, this is the basic Python layer on top of CUDA. This is QML, QD data frames and graphs and all the stuff. And then basically you have this accelerated libraries that work on these basic libraries, right? Pandas and all that. They have these accelerators that work on this hardware, optimized for this hardware, right? Rapids and zero code change, PyData and all that stuff, right? and they have various other accelerators, industry-wise accelerators as well. So with that, I would stop, okay, and open for questions, right? Ramya Bharati, do you have any question? You've raised your hand. Or you can, if you have any questions, was there a question?
If you have any question, please type in chat box or raise your hand.
Yeah, there is Chitra Murugan. I think that she has written a question here. Suppose if I want LLM to comprehend the content given in a document with relevant diagrams from the document, how to do that? When I tried, I'm not getting the diagrams. Kindly let me know the appropriate prompt for this, right? Okay, so these are a couple of things that even we have tried. So what you need to do is that you need to have your own document parser. If you just do a simple, if you just do the simple document, I do not know which LLM you've tried, but it depends on in which context that you have tried here. But one of the things that worked very well for us is we take the document, we analyze the uh, we analyze these images, we send these images to other LLM which describe that, narrate these images, right? So for example, GPT-4V can narrate these images. So we take the narrations and replace this image with those narrations, right? Even the table, typically what happens is that some of these PDF to text converters would lose the structure of these tables. So what we need to do is we need to convert these tables in the document into CSVs, and then we replace those tables into those CSVs and then send those CSVs, right? So uh, so those are a couple of techniques that you can use. Yeah, you have said I have tried to prepare PPT for class teaching. No, sorry, Chitra, I couldn't get your question, but these are couple of techniques that you can use to convert a document. First, you pre-process the document and use that document for question answer, ingesting into LLM. Okay. Did I give some, Chitra, did I give some input to your question or any other questions? Perfect. Any other questions?
If you have any question, please ask. We have time so that we can take one or two questions. There is no further question.
Perfect.
I think, sir, there is no more questions.
Super. Okay. Hey, thanks a lot for giving this opportunity to talk to all of you. Yeah, there is some questions. How agentic plays the role in GenAI, right? Swapnil, perfect. So agentic is a totally new paradigm, right? So what is happening is that As you can see with simple prompting, you are able to you know uh, create an agent by itself. So when you say that you are a teacher, or you are a HR professional, or the moment you say that you are giving the role in your prompt, you are creating a persona, right? You are creating an agent, right? That is number one. Number two is, between these agents, there is no specific API definitions, right? I don't know, whoever has asked, Swapnil, right? So these are the two things that you observe. One, you are trying to create an agent by specifying it, number one. Number two, there is no specific protocol between any two agents for communications. So what happens is, in agentic, you give a broader goal and you can let the whole system generate uh, different agents and communicate between them to achieve that goal. Okay. So let me tell you one example. Say, for example, I want to travel to Delhi on 8th Feb, right? That's all I would say. Then there would be one agent that would check my calendar. When if I have any meetings on 8th Feb in Delhi, and it knows where I am, it try to, there is one calendar that finds out the the flights, and there is one agent that can book actual tickets, and it can give me those tickets. So there is an there different agents can be created, and they can be communicated, and then you give a goal. The system of these agents can accomplish that goal, right? So that is how this GenAI plays into agentic, right? Swapnil, did I answer your question?
There is what kind of research to carry out in.
Ah, sorry, Anurag, was that a question?
What kind of, there was one question typed by Savita. What kind of research to carry out in this domain?
Oh, there are lots and lots and lots of, areas one can delve in. Uh, so at the outset, you can do a lot of stuff in prompting, the various ways of prompting, how self-corrective promptings and all those things. There are ways to, there are some areas where you see the inferencing and all that stuff. If you have some access to the GPUs and all that, you can do that. If there are other areas like domain specific, how application specific, right? How these kind of GenAI based AI, of course, agentic is one more thing. What are different patterns? You have different frameworks that are available: Crew.ai, LangGraph, semantic kernel. There are various agentic frameworks that are available. You can compare them, and you can figure out what kind of frameworks, what we should have ideally for this particular domain. And you can also work on some of these domains specifically, for example, how so clinical trials in medicine, in pharma can be, these LLMs can be used in clinical trials in pharma. This is just an example. So a couple of the list is endless, right? It depends on the your question is very broad. My answer is also very broad, right? I mean, there are various ways of various topics one can research on. I'm assuming that you're asking mostly for pursuing PhD, right? So all there are a lot of problems, research problems one can solve. Yeah.
One more question typed by Chitra. Sir, I have read a PDF and want to convert it PPT using ChatGPT. While doing so, the contents in PDF are there in the PPT, but not the diagrams. That's what I asked.
Oh, okay. So it is a so there are two things, right? If it is a limitations on ChatGPT, we can't do much. If you are actually doing something, if ChatGPT is not working, I can't. I mean, uh, I don't know how to correct the chat GPT, but definitely if you're doing some pre-processing, if you have done some PDF to text conversion and then give that text to chat GPT to create PPT, that's a different story, right? So it depends on how exactly you're trying to do. If you're just asking it to convert this PDF into PPT, maybe you should give more and more instructions in the prompt to get the PPT. Okay. Any other questions?
I think there is no more questions, so I think we can end the session now. So, Arshi,
Okay. Okay, thank you, sir. I sincerely thanks Dr. Krishna for for delivering an insightful session on generative AI based system, prompt engineering, large language models, and inferencing, fine tuning, and training. Your deep expertise and valuable insights into these transformative AI technologies have significantly enriched our understanding and inspired new perspective in this evolving fields. Thank you so much, sir. Thank you for for delivering such a nice session.
Hey, thanks everyone.
thank you, Dr. Krishna, for your session. And he was traveling from US and he just reached yesterday night, but he accepted our invitation for taking the session. So thank you very much.
Yeah, thanks a lot. It's my pleasure.
Okay.
Bye everyone.
Good night. Now we will start next session at 7:30. Can take 5 minutes, please. Debayan, are you here? You can check your slides. Debayan, are you here?
Hey, hello. Am I audible?
Yeah, you can just check the screen after sharing it. You able to share your screen?
Okay, 1 second. I'll try to share my screen.
Okay. Yeah.
Yeah, I think this is good.
So ping,
Yes, sir. It
Arshi
is
or
visible
Pinky,
now.
you just mention and
I think
Okay.
the audio is very low. Like,
the audio is fine. Actually, I was speaking low.
Okay.
okay, okay.
Sir, can we start?
Yeah, yeah, you can start.
Okay. Good evening, one and all. So let's continue with the next session with our esteemed speaker, Mr. Debayan Chakraborty, whose expertise and insight will undoubtedly enrich our session today. We look forward to an engaging and enlightening discussion on LLM agents, types, application, and future scope. So, it is our privilege to have with us Mr. Debayan Chakraborty. He is an experienced AI and machine learning engineer based in Bangalore with over 8 years of expertise in AI, ML, DL, and intelligent automation. As an associate principal at Accenture, he has led the development of AI powered solution for marketing, communications, and operations, delivering impactful results for clients globally. Mr. Debayan has been instrumental in launching generative AI products, integrating LLMs like OpenAI's GPT and Hugging Face, and streamlining processes to enhance decision making and operational efficiency. His work has earned him multiple patents and accolades. He was awarded the Director's Gold Medal from NIT Delhi for academic excellence in 2016. A passionate innovator, Mr. Debayan is recognized for his leadership in AI solution across marketing automation, content compliance, and executive decision making with strong expertise in Python, deep learning, and AI projects management. He continued to drive advancement and deliver transformative results. With that, now I invite Mr. Debayan Chakraborty to take over the session and share his invaluable insight with us. Mr. Debayan Chakraborty, please proceed.
Hey, thank you so much. I hope I'm audible to everybody.
Yes,
Um,
sir, you are audible.
so, as Pinky said, I'm an ex-alumni of NIT Delhi, so this is sort of like a full circle moment for me, like coming back to my college to give a talk.
Welcome,
Um,
welcome, sir, welcome.
yeah, so today's discussion, I'll keep it focused so that I know it's Friday night. Like a lot of us are looking forward to the weekend. But I hope like I can enlighten you a bit about what, as Pinky said, like we're going to talk about agents and their applications and future scope. Uh, 2 years ago, when generative AI came into the picture, and we were adopting generative AI systems across the globe in all of our processes, we realized one thing, that the limitation of human input and controlling the whole flow through the model talking and prompting. And for a brief while, I'm pretty sure everybody heard about prompt engineering being sort of like a very in demand skill, but that would require a person to continuously talk to the LLM, and it was not really going to a place where we were leveraging the actual intelligence of the model that was trained, or we were leveraging it in a way that the model would be more optimal to use or better suited for business or academic solutions, right? So that's where the concepts of agents came into being, and we will talk about agents today. A lot of the work nowadays focus towards your workflows, business management, solutioning, automation. All of that comes through the capability of the agent. Now, before I start, it's very important for us to understand that whenever we talk about automation or human process automation in any sort of way, we usually thought in the past as automation to be a process where we replace a human person with the work or the capability where they were doing through the inclusion of, say, a robotic process or sort of like an automated solution, right? Like, for example, we had somebody uh, who would sit in the banks 10 or 30 years ago, who would count your money and give you the amount you had requested. So a teller job was a very reputable job at that time. Then that was replaced by something called an ATM, an automated teller machine. But in today's world, when we are in a digital economy, most of you will not find yourself in front of an ATM to withdraw cash, because the requirement of cash, especially in tier one or tier two cities, is low nowadays. A lot of businesses from to top to the bottom have moved towards the digital economy, and you will see that the requirement of cash deliberately or without choice is going down. And that's where you're no longer interacting with the ATM as frequently as we would have done 10 years ago, right? So this is where the idea of how we treat agents for automation or how we bring agents into the picture, I want everyone to think of it differently than a process automation. The agent is not a replacement for a human being. Agent is a tool which will force us to think of businesses or solutions or problem solving in a way where we can harness their power and get to a better position, right? Um, so overall, like,
Slide is not moving, or it is first slide
Uh,
only?
it's first slide. I haven't yet
Okay, okay,
started.
okay.
Yeah. So I'm just giving a brief introduction on like the way we should think about it. So uh, now it's not a scare tactic with a lot of uh, uh, media going around that agents will automate your processes and automate jobs and all that. Uh, so we have to think of ourselves as people who are problem solvers, engineers or business associates, whoever we become in the future. We have to think of ourselves as people who are targeting solutions. And agents are then no longer a replacement for a human, but they become a very powerful tool to reimagine and optimize processes or create new processes which will add a lot more value than we currently have in our, say, economy, society, or life in general. So with that, I'll come to the first slide. So what is an agent, right? It is basically a system or an application which is capable to do given a task. It is capable to set out that task, do that task, perform it, and give you a result which you desire. Now, you can equate it with, as I said, like in your car factories, you have robotic processes. So, how is that different from an agent? The difference is that agent inbuilt can be taught or trained to think through the task capabilities, right? So agents innate to them have something which in the past, till the past year, we did not have in software or business processes. This was called the decision making capability. So LLMs have that capability, and agents allow us to leverage that capability to a certain degree by putting in the guardrails, by training it through the process to allow that agent to have that decision making capability. So earlier, when we were using as engineers if then else loops, when we were sort of you know I would say caught up or tied between the discrete decision making, that this is either this or that or this or that, LLMs with agentic framework now allow us to make the decisions on the fly much faster and make decisions very similar to how a human can. We are no longer limited to just discrete decision making. So even in the business, if I want, okay, up to this threshold, I wanted to do this, then after this, then maybe we can choose between these two based on the situation that arises. And that is something we couldn't code or define earlier. But now with agents that are coming in, we can now actually build those systems. So that makes it really powerful to be able to reinvent or invent new processes, right? So that's how we should see an agent, on how as we as engineers should be looking at it or use it, right? Now it has three major things. It can define a task and plan a task. It has decision making capability, and it has feedback capability and adaptation capability. Now, all of these will be maintained by a person or a human who knows these things for that particular business. We'll have to define this for the agent, we'll have to maintain it for the agent. But once we have done that for it, then it will work autonomously through these guardrails to achieve its goals, right? Moving to the next slide. Now, task definition and planning, as the name suggests, right? You have to define an objective for an agent. Every agent should work towards a singular objective, um, similar to how functions or classes were earlier there. Um, they should have that capability, like they can have multiple capability, but the objective should be similar. The abstraction of the objective should be similar. It is able to assign resources. Like earlier, if you have to say you want to do a simple thing, I like web scraping, you want to scrape certain information from the web, right? Then you'll have to code a web scraper, integrate it with your other code bases, get that data, sort of pull it in, right? Agent can use that web scraper capability as is, as an inbuilt functionality. It can initiate that package, it can run that functionality and get the information. So you do not have to explicitly define and code that. You can say, this is my package, this is my resource, you have to use it. Environment assessment, something which softwares earlier did not have, now agents have. Where it is being used, what are the sensory inputs that are coming in, right? All of these are things which earlier again were very discrete, in the sense which will call something like triggered agents, like there's a trigger point to a certain signal coming in, and then the agent starts, right? But now with environmental assessment, there are certain levels of sensors or certain continual sensors where we can also leverage agents, and they will be able to give us those information or work accordingly, right? And the last thing is plan generation. Now, ideally, it should be defined by persons who are employing that agent on a process that they know about. But in case they don't, an agent is able to break down a difficult task into simpler tasks. And all of this is, of course, because of what an LLM is capable to do. But at the same time, to harness that, we have to make sure of using the agentic framework. So the is basically, agents are frameworks which are built over LLMs, which are trained or sort of developed with these capabilities in mind. So you're no longer just giving a blind prompt engineering or giving a prompt and getting an output. You can now structure your thought process in this framework, and the agent works accordingly. And as I said, decision making is one of the key capabilities of an agent, where it's able to analyze the data and execute the action. And feedback and adaptation, something which till 2 years ago we wouldn't have thought about softwares to do. And especially in ML pipelines and deep learning pipelines which we developed, we had something called continuous integration and continuous development. So with CI/CD pipeline, we were able to have feedback, continuous feedback into the system, and retrain the model, and then um, sort of like deploy the model again with a better performance, right? So all of these concepts of ML ops, LLM ops were in the picture, which were basically flow of the information, keeping track of how my model is doing, and then continually updating my model, retraining my model, and all that. Now, that infrastructure itself is extremely costly to maintain, number one. Number two, that information is also very hard to come by because most of the ML and DL solutions are employed on processes which are not structured. We work mostly on unstructured data like images, videos, text, data lakes, not databases. So there are no set guidelines or guidelines for using these things, right? So now for creating those CI/CD and continuous feedback loop and retraining my model again and deploying, that whole process required a lot of money, a lot of infrastructure, a lot of time to develop every time and maintain. And also they have a huge support requirement because even if one of this whole system goes down, it breaks down the entire system. Now, with agents coming into the picture and the capability of LLMs, we no longer require that to be that complex. The feedback loop now becomes simpler because agents themselves do not need that much data to be retrained. They can work on simpler data or smaller amount of examples, and they can identify business rules and rule-based definitions and can be objectively defined to work on. That's where the feedback and adaptation becomes a very powerful concept for an agent. Now, all these three things, I'm giving an analogy of how they worked and how they're going to work with agent. Why I'm doing that is this is nothing new from a process standpoint. This is how softwares are usually developed in businesses for the past 30 years. But right now is sort of like a time where it is going to become extremely fast and it is going to force us to reinvent ourselves quickly. And we have to think of software development and business impact of software development much differently than we did earlier. Moving forward, right, the components of the model, as I said, AI agents are usually frameworks which are built over an LLM. So the basic AI model, whichever large language model you use, they can be multimodal as well. So they should be your foundation. It can be Llama, it can be BERT, it can be ChatGPT, whatever you want to use. Now, sensors, of course, if your agent perceive a system which is physical, it needs sensors to interact with the physical world. So you'll need sensors. And actuators are the ones which allow the agents to make those actions. Now, there are physical actuators, there are software actuators as well. So usually in software, we use logical actuators to make a decision or take a step in the process. But physical actuators will be like motors and rotors, which we use for robotic movement, right? So yeah, any question till now? Okay, I take that as a no. So going towards with that concept in mind, we can now go in because of the autonomy that agents have. They can work individually, given the decisions, given the feedback, given the planning and the idea. They can work individually. So that would give us to the next logical step that can it work with another agent? And that is where a multi-agent system sort of comes into play. And this is something that a lot of companies, including Accenture, is currently working on. I would have loved to show you, but as you know, it's pretty state of the art. So a lot of it is under legal issues. But what basically the idea is that it came out of that notion that if an agent is to some degree intelligent, if an agent can to some degree take feedback, give feedback, and plan, can it work with another agent in tandem to to achieve a common goal? That's where the multi-agent system comes into play, right? And these agents can then sort of become a chain of agents or a group of agents who work towards a common goal and make the software engineering solution more robust and much more different than how it is going on right now. And robustness leads to scalability. Now, each unit of that agent, so each individual agent, is a very small unit of the software. So that leads it to be extremely easily manageable. And then the integration of agents, capability of interacting with each other, also becomes very easy rather than earlier where we had multi um, sort of container systems, right? where we would have one place, we would have databases, data lakes, servers, and all that, and we would be working night and day to code chain links and APIs and gateways through it to make a solution work. Instead of doing that, we can now employ agents in all of those situations who will be specialized to do exactly just that one task, one or two tasks. And these agents will come together to reach to achieve an overall goal. And that's where like a software is to be reinvented in the form of an agentic solution rather than reinvented as a human automation process, right? So to give you a very simple example, going back to the bank example, right? Um, the ATM machine today is sort of going to be very soon a relic in the sense that we no longer have that frequency of interaction with it. In fact, you would have noticed that the number of ATMs around you are going lesser and lesser every day. And this is where the process has been reinvented in such a way that the requirement of cash has now gone. Earlier, cash would flow through the system, and it was very important that you had in hand cash. Now, the banks itself will hold the cash. And if you need for short transaction, the banks will then sort of act as a trustee between you and the business, where you do like simple short transaction over the digital platform. So the requirement of cash is now gone. So the entire
Ex-
process of the supported cash is now no
uh,
longer required.
Sorry to
Yeah.
interrupt.
Go
Actually, your slides are not visible to some of the participants. So, can you please reshare your screen?
Okay. 1 second.
Yeah.
Some of the participant it is not. Maybe after reshare.
Okay. Resharing.
Oh, please comment chat box is well.
Is it visible now?
Participants, please drop your message in the chat box that it is not visible or visible to you.
Arjun Davla. Deya Prakash, what about you? Angel Raja. Ah, visible. I think it is visible. Go ahead.
Yes, sir, it's visible now. Please
Okay.
proceed, sir.
Well, yeah.
Okay.
So as I was saying for with the bank example, so does that so what has now happened is the entire flow which was there for supporting cash is no longer required. But now the flow is moved to supporting the digital platform. And that is how we should see software engineering now. Now, very soon, we won't require that much of a presence to handle the software stack itself, the application stack, basically, because that is the main pain point of software development, where all the teams are working on their own application. So now we will have sort of like a global place where each of us will host our own agents, and the agents will be orchestrated together at a certain level by an orchestrator, a human orchestrator, who is then going to create solutions out of the capable agents, right? Sort of pick and choose which agents I need to do a task and create that silo, that network of agents and that, right? So overall, that is how we will reinvent the software development process. Now, with that lead to lesser developers being required? Um, Definitely, but will that lead to a more um, robust development framework? Absolutely, because now people will be more, the engineer will be working towards much more complex system through much more simpler means, and they will be able to handle the business problem at a much more robust scale. Now, going to the next like benefits, right? Automation becomes efficient. Um, there's decision making in the system, innate in the system, other than the human input. The human will now basically be sort of like a fact checker solution where it is going to see how good or bad the decision making is done, and they are going to then uh, tweak the flow of the system or break it as per their requirement. Um, there's going to be reduced human error because less and less involvement in the software maintenance will lead to reduction of human error. Increased availability because of these agents being a simple unit of work, and sort of like aligning them or arranging them together becomes very simple. The availability of them is now you do not need to wait for somebody to come to you and create a web scraper or create a website. You have these unit agents who are targeted to exactly do that. So if you want to create an end-to-end solution where you want a website, you want to create sort of like take an order and book an order and get it done, you can do it simply with much less human requirement. And increased safety is one of, because today with the infrastructure requirement, safety becomes an issue. But when your application layer is now decentralized, it's just no, it's there's no longer uh, infrastructure involvement. It's just agents in silos who can work together. The safety of it is much improved. And cost saving and scalability, like cost saving is, of course, it's trivial, but scalability, because the unit of work being simple, the solution scales faster. So if we look at even houses being built in the West today, or even in India, if you look at high-rise building for big developers, you will see things called modular development, right? Because we have simplified things to a lesser unit of that development. If you consider a kitchen, you have the unit of development required for a kitchen. You need cabinets, you need microwaves, you need gas, you need oven and whatnot. So then creating the solution for that, for a particular space, becomes very fast rather than you entering it, you're designing that entire kitchen from scratch and try to make it, where the cost and scale sort of becomes a bit of a pain issue. And if you want to change the outline of your kitchen or the layout of your kitchen, you can't do that quickly. But if it's a modular kitchen, um, you would see like in the West or even in some of India's big builder houses, you can change things. You can move one, you can move your shelf towards the basin, you can move it out, you can replace one shelf with another. So all of these things lead to scalability. And that is one thing with agents is going to be make it much more easier. So if you're a small business or you're just starting out as a startup, agents will make your life much easier to realize your business solution than it was doing earlier. Now, coming to the types of agents, right? As I said, triggered agents, a simple reflex agent. It's something I think all of you are doing to some extent when you interact with ChatGPT or when you interact with, say, any of the large language model and you ask it to do a task. Say you ask ChatGPT to give me the latest Wikipedia data on Sachin Tendulkar. So what ChatGPT is doing is employing a web search agent to go to Wikipedia, pull that data and show it to you. Now it was a trigger that you told ChatGPT to visit Wikipedia, and that trigger would then tell it to go there and get that data and find it. Now ChatGPT is following a one-to-one step that it is doing. Does it have memory? No. Does it have any decision making? No. It's just following the task which was laid out to you. Um, it just chose to use a web scraper because that is the only thing it can do to go to Wikipedia. So these things will be called simple reflex agent. There's a simple trigger to start it, and with that trigger, it is able to achieve its goal. Model-based reflex agents are similar to this trigger now, but the one thing is there will be an internal state of the model that is going to be maintained. A lot of the agent solutions that you'll see in and around you, even from colleges or universities or even from corporate, you will see they will talk about it being intelligent, it being scalable and all, but be very critical and see that how many states does it have innately in the model. If it has only one state, then it is still a trigger agent. It's still just gonna do one task. It has only one state that is defined for it. And being on that state, it is going to take a decision. rather than a generic reflex agent, which comes as the generic LLM platform. Once you've defined a state for an agent, say I today want an agent to make grocery shopping list for me for the next week. I will tell the agent that, okay, your target is only to do grocery shopping, and this is the list of shops that are near me, and this is the list of items that I need every week. Now it has a state defined for it, that these many items is what it can choose from, and these are the shops it can choose from. Now, from that state, when I ask it, give me a grocery list for this week, it is just going to make a next level, next step decision that, okay, I have the state, I know what is the information, I'm going to take the next step, I'll give this guy the grocery list. So this is what is a model based reflex agent, a state defined reflex agent. It again, it doesn't have a goal, it doesn't have any utility in the sense I cannot integrate it with other systems. And even if I do, like, there's no innate intelligence to this. It doesn't have memory, which I'm going to come to, one of the most powerful things. And it doesn't have decision making capability. I haven't given it any thought or any sort of guidelines to follow and decide on the point what to do better. It's just following a task. The next one is very important, is the goal based agent. Now the goal based agent comes where is when you're entering into the abstract domain of an agent. There, the agent is now going to decide based on the goal that you have defined. It's going to decide real time what is the best choice available for it. And that sort of like then grows into a system which can then support much more complex problems. Okay. And so it will require guidelines for achieving that goal. It will require steps for achieving that goal. And then on the basis of that, it will create strategies. It will create that what can I do next? And then it is going to choose the best possible option given in the system. Now, every agent, if you work with agent frameworks, will come with two things: functions and utilities. Now, utilities are different from utility agents. I'm coming to that. So, functions are sort of as software functions are. These are predefined functions which do a particular task. And utilities are sort of software packages or software solutions like say a wrapper or a web scraper or a database management system, which are targeted to do just one thing, just handle that one thing, right? So from the goals and strategies that they have defined, now the agent is going to decide, okay, which of these utilities I can use, which of these functions I can use to get to my goal, and then they are going to work towards that. So that is where a goal based agent, as you now can understand, it is no longer being triggered by an input. You given an input, it is now thinking exactly, like it is mimicking thought. We cannot say it is completely intelligent because we are giving it the guidelines for the thought, but it is now thinking, mimicking that thought and choosing the best strategy for it at that moment. Coming to utility based agents, these are similar to goal based agent, but they will be more focused on the utility, on what they are trying to do. So I can have agents like search agents, which are focused entirely on web search. I can have image understanding agents, which are focused entirely on image understanding. I can have author agents, which I will have guidelines on how to write something. Say I want to write an advertisement or I want to write a Instagram post, and I can tell that agent, okay, you're an Instagram author agent. So I can train it on how to write an Instagram post, and then it is going to take that and be focused on that utility. Now, as you can understand, utility is sort of like a subset of goal. And so an utility agent will take a decision as well, but it will take a decision in smaller decision space. And so that's where an utility agent will come below a goal-based agent, because the goal-based agent has to strategize at a much bigger scale, where a utility agent will has to strategize at a much more smaller and much more focused scale, right? Multimodal agents is the agents who can work with multimodal data. That is like agents who can work with images, PDFs, PPTs, all of that, right? Now, although, like I said it simply, this is a very powerful thing. Uh, Going back to solutioning or AI solutioning and even software solutioning 2 years, 1 year back, imagining handling input data is one of our biggest pain point, because input data can be from many sources and many types of data, many types of system, right? You will think it's trivial because at college level or a academic level, there are only these many systems which are employed across the world which we interact with. So it looks and feels very simple, but if you go into the corporate or the corporate research world, you will see that the cost element will lead to choices across the board which companies have made with many systems for data management. And there are millions of data management systems, right? So to integrate those in as our input into a software solution, well, is the biggest and the most important, I would say, and the most time-consuming challenge that we face. Now, with the multimodal agent, this is an agent capable of handling any sort of data, and that becomes sort of extremely powerful to speed up our input layer design and input layer solution. So no longer I'm having to go to multiple systems and sort of understand, okay, how to get that data, how do I process it, how do I analyze it, where do I get the exact form of it, right? Now this I can just get the uh, embedded version of that data and I'll pass it through my multimodal agent, and it can then choose, okay, this is an image, this is a text, this is an Excel, this is a database, and it's gonna interpret that data accordingly. So this is one, or it is an audio or a video. So this is a very powerful sort of like thing which is making software development life much more easier, right? Uh, Going to the next one. Okay. Now, what are the future trends, right? Again, like it's going to have a widespread impact on making, on cost saving, on making software development easier, healthcare cheaper, transportation easier, manufacturing easier, and customer service easier. Now, customer service you're already seeing where all the services and all the websites or all the apps you use today no longer have call agents. They have software agents who work with your problems. Now, till last year, these agents were not capable with for this level of decision making, but you're going to now see that the agents you are going to interact with in the coming days will become more and more intelligent. They will become more and more aware of the company guidelines of the legal policies, and that interaction with customers are going to become much more easier, and solutioning for that is going to become much more fast and easier. So that's where systems are going, and at a pace which is like it's light years. 2 years ago we would have thought we would get there 20 years later, but it's we are passing distances like in light years right now. Like we will reach it in within a few months. Healthcare. So one of the major impact of the agent workflow is in the marketing standpoint, specifically healthcare industry, which is something I work in. So healthcare has a support function where they have to go through a lot of legal and marketing channels to propose a drug to the audience. Now, to do that, they have to go through a lot of legal channels, lot of corporate channels, and it is you shouldn't think when you're solutioning for these problems. Do not think just in the India scale. Think in the global scale, because when you think in the global scale, this becomes an extremely important legal problem. A single mistake in your corporate marketing for a healthcare company can cost you $1 billion or more. If today you accidentally do a marketing for a cancer drug which is targeted to people between 30 and 40, and you accidentally use a child's image in that marketing campaign, you are liable to $6 million up penalty, because you, to some degree, portrayed that a child can be given that drug, which is not the case, right? So that's where these legal people, these creative people, a lot of them come in and design and then plan and sort of do these marketing shoots and marketing design. Now, what happens to this data afterwards? Like they have these photographs of the product, they have these videos, photos, these whole marketing content that they have created. They are just lying there in a digital database. They are not searchable. They are not as well maintained as Google searches, because these are all protected and private data. They are not, you know, they're not out in the web. They are not tagged like Google tags their images. So they are not easily searchable. And these cost the company millions and millions of dollars to do, right? So today, if I have to go back and sort of think of, okay, I made a marketing for this drug last year for US. I want to do the same thing for India now. Can I use that same image? I can't. So now again in India, I have to find a creative person. I have to find a legal team. I'll have to create a whole flow, spend the same amount of money to create a market for India, right? I'll have to find models who represent the Indian demographic better. So all of these becomes problems of scale. And if you objectively analyze it, this is not very intelligent problem. It's just I'm having to repeat a process again and again because of where I am, because of the situation. Now with agents and with LLM capability, what are we able to do with image agents? We can now reproduce that data with slight changes. So I can create marketing campaigns where I can change the model to look more South Asian. I can ask the agent to validate my marketing campaign based on geography. I can ask it to check for my marketing output and check whether it's meeting all legal guidelines. Things which would earlier require me to go to a third party, bring in a lawyer, bring in a copywriter, bring in an entire suite of people to help me do. Now a simple agent can do that for me. All it needs to know is what is the legal guidelines of that country we are working with. And it is very easy to give it to that. Right? Once it knows that, it can then objectively strategize and make the decision and give me, okay, these are the errors that I see, these are the possible errors that I see. And sort of that abstract decision making, which earlier software systems won't give you. They would give you a threshold that 60 to 50% this might be a problem. Now this can objectively give you that this might lead to a problem because of these catch. So then you can make your marketing campaign much more better, much more robust for the geography you're targeting. Transportation is also one case. So if you know, transportation works through invoices. So invoices go from one place to another. People sign invoices, they sign, they stamp, and sort of like one person creates an invoice. The person who receives it, you sign on it, right? So like an Amazon package comes to you, sign on it. So you're the last delivery person who have validated that you have received that product. Now from the factory to you, that product goes through an entire transportation life cycle, right? And at every point, that data is updated to a system. That's how you get the tracking data that you see on any of your e-commerce website. Now, in today's world, these systems are not homogeneous. There are multiple companies who are employing multiple data services. And so it is extremely tough to create a simple flow of diagram of where your document is. But if you would have noticed, Myntra and Flipkart in very recent times, their tracking has become extremely targeted. And yeah, Amazon as well. It can tell you exactly which state, which city, and which factory location it is in. That's because these agents that have been now developed, they are simple unit of work. That all you need to do is understand from my invoice which location, which city, and which uh, factory it is in. That thing, the agent from that invoice can now, okay, this is the invoice number, there's something called a bill of lading number. That is a number which is added to the invoice at every juncture, telling the code that this is where the product has reached. From that number, it can now look up a database and see, okay, this is exactly this city, this state, this warehouse. And now if you go to your Amazon or your Flipkart or your Myntra, you will see that you can get that granular level of detail of tracking of your transportation. Earlier, which would require me to employ a third party customer service, a validator, somebody on the ground who would check all of these data for you and tell you, okay, this is where your product is. Now it just needs one agent to do an end to end for you. So that reduces cost, and overall logistic cost reduces product cost. So now if a product is coming cheaper to you, That because the lesser number of middlemen are being paid. And that's where like you will see the importance of the transportation impact, right? And at the same time, machinery is already pervasive. Machineries make a lot of our products. So machinery agents were anyway a big deal of in automation in the past decade. But now something which is going to come even more is objective quality analysis of the product that is developed. That still requires a lot of human intervention, but that is can now move with the advent of better vision models, better system, which will be better equipped to capture any blemishes or any wrong product development and can move it out in the manufacturing cycle. So that also reduces your cost, right? And lastly, as I said, customer service. Now, where will it be less use, right? Now, you have to understand these agents currently are at an infant state. It's great to see them in certain silos, certain places where they were very easy to pull in. But when you think from an overall global standpoint, from all the problems and the consultancies and so many companies working on so many things, right? We cannot put in agent to simply replace a human being, because then that it's impossible to train a particular system on how to think like a human for that particular role. We'll have to rethink processes entirely to support this agent capability. Agent has shown itself that it's an extremely powerful tool if we can simplify that process to a simple unit of work. So now in the future, as software engineers or as business professionals or as researchers, rather than just thinking about the software improvement, we should be thinking about the impact of the software improvement. We should be more outcome driven rather than achievement. Whatever earlier we would, as many of my professors would say, research we would look for the next sort of delta level step. Now with these agents in your toolbox, in your power, that list of next possible delta is very easy to find. Put in, like, say, take 50 of the latest research papers, feed it to an agent and tell it what is the next possible steps that can be taken. And your agent is going to give you at least 100 or 200 steps that can be taken. Now, as a researcher, you have already halved your time by 6 months. You did not need to go through those papers or do any of those critical analysis to think of the delta that you want to do. Now, out of those 200, as a researcher, it is now your task which one is the most objective and the best possible solution that you can achieve. And you can sort of give that impact to the world. And that's where you can now focus on more. So all the pain points of a researcher, all the pain points of a developer, all the pain points for a business professional are now going to just reduce at a large scale. So we are no longer going to spend time on those simple input problems. We are now going to focus more on the actual problem endpoint. And that frees up time and that frees up money as well. Because if you understand, like, as a just out of college researcher, you can compare packages and all. But as you become an expert in your field with 20, 30, 40 years of experience, each hour of your day is an extremely costly affair. And people are paying for your research, people are paying for your upkeep, right? So by freeing you up from the more sort of like rugged repeated tasks, your sort of time is now more better equipped and better utilized towards getting us more innovation at a faster scale. That is all that these agents should be focused on doing. They should not be focused on automating simple things, because that is anyway innate, that's given, it can do it. But to employ that one single agent to automate a simple process, it's too much of a cost you're putting in, because you have to understand an agent is supported by an LLM, and to run an LLM is a very costly affair. So your impact cannot be small, it has to be huge. So that's where you have to think the problem at that scale to make that impact. So that's where I say, like, simple problems, ground level problems, although as projects or as learning, great things to do to showcase your capability. But on a global scale or on a business scale, I would say the impact of that is much lower and shouldn't be seen in that. Now, advanced future is theory of mind and self-awareness. Theory of mind is something I think a lot of you would have heard of. It's based on knowledge-based knowledge management. I think a lot of you joined KK's discussion earlier. KK is one of the leading knowledge management researcher in India right now. And so he has been working in knowledge management at IBM Watson since 1993. Knowledge management is one of the most important problem that has come into picture because of this agent, because of the theory of mind. Now, given you have three things which agents can do, it can decide, right? It has understanding capability to some extent, and it can mimic thought. So now, if I can give it the mind knowledge, if I can give it a digital brain, what can it achieve? So for every problem statement, think you're in multiple business problems or multiple academic problems that you do. Say you've created the knowledge base or the mind which is totally focused on quantum physics, or you've created the mind which is totally focused on nonlinear mathematics. That sort of information you have managed in such a siloed way that now you can employ agents to just click on that knowledge state or that knowledge base, and it can give you that knowledge in a distilled, consumable, and much more effective format than earlier you could. Earlier, to go to a library, we then move to digital places where we have PDFs, HTMLs, information galore. But what is the problem with the information superhighway that internet is? You still need to spend your time to search the most relevant data. You need to spend your time to validate with somebody, possibly an expert like a professor or a senior researcher, that am I reading the right thing? And you have to think that, okay, what is the impact I can make from what I am reading? Now, with the theory of mind capability, you have an entire brain which is suited for that. You can ask it these questions. You can get that data from it, right? This frees this the impact of it is unfathomable. It's freeing up a senior researcher's time. It's freeing up a senior professor's time. They are now better equipped to do much more important things. And you are at a level where you can now interact with that mind, get that information quickly, and you can choose it to target it for yourself, because this mind, powered by an LLM, is also capable of distilling this information in a simple, consumable form. So if I start today, say I want to learn something about quantum mechanics, I know nothing about quantum mechanics. I can then employ this mind and say, teach me like a 5-year-old. Now, when I'm good with that, I can say, teach me like a 15-year-old. Then I'm good with that. Then I can tell the model that, okay, I'm doing college level physics. Now get me to that level, right? And one of the problems that we have always had, right? If we go back to classroom education and all that, think back to in classes when your professor said, okay, they are showing you a formula and then say, okay, so the next step is this, which the next step is probably referring to a formula which you have learned in some other numerical class, right? And then you're at a thought, okay, I missed that because I don't remember that formula and all that, right? Now, with a mind which is trained for that information, you can just tell it quickly that, okay, how, and you're no longer needing to stop the class. That assistive tool is open with you. And that mind can give you a very short, like 200-word excerpt. Okay, this is how it happened. And then you can go back to your class and follow the rest of the lecture. So now learning becomes a very interactive, very quick, and no longer something which will give you stress, because you no longer have to wait the 45 minutes to either ask the professor or go back home, search the book. You're not doing any of that. You're now interacting with a system which is targeted to that problem. And that makes your life much more easier. Yeah, the last thing is agent swarms. This is something which I still think is sort of like a dream of us researchers. So to employ an agent swarm is to have this hive mind at a level where they are all in synergy with each other. That will never, that is sort of like problematic. Think about it. Like um, we as individual human beings have different sort of mindsets, different sort of capabilities. And whenever we try to interact with each other, to some degree, there's a friction that we face. Even with the most similar sort of people, we see friction. So an agent swarm has to be designed in such a way that this hive mind or this theory of mind is scalable and at synergy with each other. And then an agent swarm can be developed. Then sort of like you can have agent systems which are, say, I have quantum mechanics agents, I have finance agents, and then I can sort of ask them, okay, work with each other and then employ the next best solution to create an algorithmic trading platform. If you know, a lot of quantum mechanics people have developed algorithmic trading platform under the guidance of finance people. So now these agents together can do these things. And once that is developed, us as humans, it's our job to just validate that which one is better, which one is indeed better, indeed correct, and all that. Having reached that level of expertise. And an agent swarm will basically scale to that level. Now that you have the algorithm, work with a deployed algorithm to deploy that algorithm in the trade, work with a trade algorithm to perform the trade. And so all of these agents will work together, create a swarm of activity, and achieve the common goal, which might be like get the best out of a trade, right? So these are all things that are coming towards the future, and hopefully we will reach there within the next 10 years. But with the way things are going, don't be surprised if we reach there within the next 5. Because one of the challenges of achieving these are infrastructure. And as you might have heard with NVIDIA and all the funding that it's getting, infrastructure cost is going down. So the cheaper your infrastructure is becoming, the faster this is going to go. Reinvention of processes, thinking of solutions in a different way is going to be your main value add as people. And that is what we should all strive towards. Now, before I close, I want to leave you with one particular paper which I found is extremely impactful. Um, it's called Agent Planning with World Knowledge Model, right? So the world knowledge model is basically a simulated environment. The world is a simulated environment. We give it particular knowledge or steps to the model, and we train the model to think and synthesize its own strategies or possible steps in that model with this guideline. People who might have learned reinforcement learning would have heard positive reinforcement, negative reinforcement, similar to that. So we are going to give that education to the model. And then once we are at that world knowledge level where the model has learned about the possible scenarios, has strategies about what it can do. Strategies can also be shortcuts. So once the model is doing that in a dynamic way, then how it can plan a solution, work on the solution, and act out the solution. Now, as I said, the world knowledge, once we give it the steps it can take, the steps are states. So you can think back, if you're a computer engineering nerd like me, you can think back and think of it as this is the first time we are seeing finite state machines being achieved in actual living problem solutions. So actual deployed problem, production problem solutions, academic problem solutions. This is the first time you are seeing finite state machines in employment. They are actually working to achieve this. These finite states are being maintained across in the form of the world knowledge or the simulated environment knowledge, and in the form of the strategies which the model itself learns from that simulated state. So it creates its own state as well. And then it interacts with the state and creates its strategies and takes the next step. So before I dive into that algorithm and complete this talk, I just want to show you a bit of Accenture's view of how agents should be. Um, and this is available on the web, by the way. This is Accenture's AI global strategy. You can just search for this and you'll get that. So overall, any system which will employ agents have to be thought of in the agent way. It cannot be thought of as an existing human solution and we are just processing input places within that solution and making it orchestrating solutions for those particular silos where humans are working. We have to reinvent that solution to see how agents can be maximal or optimally used, right? So overall, every system should now then be thought of as an orchestrated system where there's a global orchestrator run by a human or trained by a human where that global orchestrator is now going to orchestrate this activity or these actions, right? These orchestrator will be parallelly controlling super agents. Super agents are who understand the human intention and who understand the goals. And then these agents will work with utility agents who are more siloed to a particular piece of solution. And these super agents will employ the most relevant utility agents based on the problems and then scale that solution up. So this is sort of like one solution paradigm which Accenture is given. This is very similar to what Crew.ai is also doing. And they also view the agent platform of the future in this format, where we have a hierarchy of a orchestrator agent, a super agent, and a utility agent. So going to the world knowledge agent, right? Now, traditionally, when the agent concept came out last year, by the way, not that far away, traditionally what people were thinking is from the human reinvention perspective, which is existing process, what can we do, automate and no longer involve a human to do. And so then we were employing agents for those particular cases. The problem with that is it's extremely narrow. It doesn't justify the LLM cost itself. But at the same time, it is not employing the agent's capability of having a memory and its capability of decision or thought. So these three things, what needs to be there for the agent to do this? For the agent to do a process with these three capabilities, memory, thought, decision, it should have a memory of what the process is. What the process is translates to what are the states in the process, right? And then what are the like think back to a state diagram or a graph where each state has is sort of like a network graph, and it has connected direct acyclic graphs to connected other states where it moves like a finite state machine. So that knowledge has to be employed to the model, to the agent. It has to have the state knowledge. It has to have the world knowledge. The world being a simulated environment, within that the world the process is running, right? There can be multiple processes running in that simulated world environment. So for that world knowledge, it should have the state knowledge of the process, and it should have the task knowledge of that process, like what tasks can be done on those states and how does the state change based on the task that I have performed. This is the memory and the decision power that the model that the agent needs. Now, on the basis of these two information, it is now going to strategize given a task. It is now knowing the states, knowing the next possible state given a task, knowing how the world model restricts me from taking a step, or restricts the agent from taking a step. This will now theorize and strategize the possible next steps it can take. It is now going to give sort of like a threshold or a probability approach of what is the best next step to be taken. And then finally, it is going to take the most optimal step. In fact, that is the theory of this. And once this was developed, so this has been developed by ByteDance and people in Google DeepMind. And once this was done, they saw that in fact, that is the case. Once the agent knew the simulated environment, it knew the state machine, it knew the task knowledge, it was able to theorize and decide absolutely correctly to a lot of high degrees, like high 90 degrees of accuracy. What is the next possible path or step to be taken to reach or achieve that common goal? Um, to highlight that, I'll go to the last slide. This is where you will find it has given sort of how the training and how the actual work happens, right? So in the training, we are giving the state knowledge and the task knowledge. So the state knowledge tells me the states of the process. The task knowledge tells me what are the tasks that can be taken in that process. And then you will see a very interesting thing called task knowledge synthesis. So it's synthesizing the task knowledge. I'd urge all of you to just write down this heading, agent planning with world knowledge model. This is the very first paper that comes in, up in Google. You'll find the same image. You should all read this to really understand what an agent is capable of, right? It's an extremely easy paper to read. This is a very theoretical paper. Math is minimal, but there's a bit of math, but it's extremely powerful a concept, and they have shown how it has achieved what they have set out to achieve. Right now, the second thing is the task synthesis. Synthesis being from the state, from the task. Now the model is asked to synthesize more possible steps or states that the model or the agent can itself make. So basically, think about it in your day-to-day life. When you entered the college or when you entered a system or an institution, you did not know anything about it. You learned how the process works. You learned how you get an admit card. You learned how you sit for an exam. You learned how your timetables are given, and all that, right? And then you arranged your day around it, right? Now, think within a month or two, you now have shortcuts. Um, you know which teacher to actually reach out to for getting the admit card faster. Divya might have a question. You know, okay, we'll come to that. I'll complete this and maybe Pinky, then you can pick that up. So after a few months, you are optimizing processes. You now understand, okay, from my college, if I have to go to uh, computer lab, I'll probably take this gate today because the computer lab is nearer, then go through the front gate, right? So these are not steps or states that are written in any process document, but that are being taught to you by anybody on the day you join the college. These are things you're learning from experience. And that is the same thing which a knowledge task synthesis is being done with with the agent. It is being told this is the state, these are the possible tasks. Now optimize it, figure out shortcuts, figure out what else can you do, what else can you do parallelly. So now the agent is creating a synthesized task state, which is a separate state diagram which it is creating according to its understanding of the process and the limitation of the world model, right? And this together is now a very powerful state machine for the agent to refer to. So now when it goes in an actual step where we ask for it to, okay, take a step to put the newspaper in the drawer, or uh, write an email to my colleague saying that I'll be off today because I'm not doing well. So now the agent with the state knowledge, the task knowledge of the process, say for the email case, it will now check my organization information in my organization website. It will know exactly the people it needs to inform in case I'm taking an off, which is my reporting manager. And it is then going to draft an email to my reporting manager. Then in the last few, it's going to check my team's history because in the last few days, it is going to see who I'm interacting with the most. That will give it an idea. These are the people I'm working with. If you are using Teams, I've heard NIT Delhi is using Teams as well. If you open your organization chart, you will already see that in your Teams. Teams also captures that information, who you're working with. So then the agent also will have that information that who I'm working with on the daily. So it will make an assumption, okay, these people might also need to know he won't be available today. And then it's going to add it to the email. It's going to draft that email, add my signature, send that email for me. This is where its knowledge synthesis, its state knowledge, and its world knowledge enabled it to take such an informed decision and do an extremely complex automation, which earlier would not have been so easily possible, right? So, yeah, and because the agent resides on the infrastructure of Microsoft Teams itself, the security requirement is much less. If I have to build a system which does that, I'll have to first create an API which reaches out to all of these systems which have this information. That is a security overhead. I'll have to get that information from Teams to my software, to my program. That is also like a security overhead and a wait time because these are like slow databases. And then to decide and sort of draft the mail, that's another few hundred lines of code. And then sort of hosting that program into a certain scenario, into a place where it runs and in tandem with Teams. So an infrastructure cost. Now, if I employ that agent on the exact infrastructure which Teams is working on, which Google Teams or which Microsoft Teams is doing, you'll have GitHub agents and Copilot agents in your Teams as well. Very soon, I think it's still in beta, but if you already don't have it, you will have it. So then automating this process becomes extremely easy now. And there's no security over it. It's working on the same infrastructure where the Teams is. It just needs the information that Teams has, so it can pull directly from Teams. And since it's on Teams infrastructure, it doesn't need any security clearance for that as well. And you can draft the email and send that email from Teams itself. So that is the power of agent planning, of world knowledge, of states, of understanding the global process, right? Uh, Now, if you compare the example I gave you of how a software would be written for achieving this goal and how an agent works, you will see the agent process did not require me to think about the input, think about which systems I'll have to get the data from, because I'm in the infrastructure itself, right? So that the entire redesign of the process was not taking an existing process, thinking how to optimize it. It was just throwing out the existing process and think how can I achieve with the agent. That is what from this talk I would expect that I give to you all, that in future, in the very near coming future, forget about your waterfall models, forget about your cyclical models of software development. Think about from a global perspective of a problem that you're solving. And that is how agent-based solution design will drive the future. With that, I will close my call. I think you have been a very nice audience. Thank you. And if you have any questions, please, Pinky, you can take over. Hello.
Any participants, if any question, then please raise hand or can unmute also. Question is typed in chat box. Evan, can you read the question in the chat box?
I'm not getting any questions in the chat.
How cost is calculated?
Oh, cost is calculated based on where you're hosting your model, where your servers are, and on the tokens. So every LLM cost is number of tokens you're sending to an LLM on a particular request. You will find that cost sheet for all LLMs, even for ChatGPT, online in their website. You just need to log in. You will get that cost sheet. And then you can calculate on your day-to-day use, like how many tokens you're using and what is the overall cost of that. For corporations, the additional cost is the model hosting cost, because I cannot, I do not talk to ChatGPT in OpenAI's platform. We have bought a ChatGPT model for our organization and we host it in our cloud for security purposes. And for that hosting and that sort of infrastructure or GPUs and CPUs, we have to incur a cost for that. So that is the overall cost that we calculate.
Other question. One more question. The difference between AI model and
AI model and LLM. Okay. So a large language model is something which is from an existing AI model is overall a generative solution. They are they come out of the concept of generative adversarial networks and your transformers, right? So from these two concepts, the concept of a large language model comes up. There's a generated discriminator framework which learns the pattern in the text, and that's how generation is the probability of generation becomes better. So what if I have to simplify, because the mathematics of this is very very difficult. I think the audience distribution is across the board, right? Um, so like, or are they all PhDs? Like, I don't know. So, should I deep dive into the mathematics of it, or should I simplify it? What should I do? Okay, I'll give a simple answer in the sense that generative adversarial network and transformers, right? Transformers, the scale, if you know, there are the concept of attention and the concept of YOLO. YOLO, only look once, right? So, and self-attention, that is given a piece of text, it is able to read it frontwards, read it backwards, and knows the probability of the next possible text after that piece of text. So think very simplistically, if I said, hi, my name is Dash and I live Dash. So from a large corpus of document, the model is trained that I live in Dash possibly leads to an address. So then the document learns a pattern of this is an address, right? And a generative model then is employed to generate this outcome from a data, from its training data. It tries to generate this probability of the next possible answer. Initially, this generated outcome is absolute garbage, is absolute crap. And along with that, there's a discriminator. A discriminator is the one which has the actual next step in it. So you have to create your data in that format, generation and discriminator. And then the discriminator tells the generator, this is the next step probability that you gave. The next step probability is this is wrong and this is the correct. So then we calculate the loss of the probability between these two. And then it goes into the feedback through the back propagation and all the feedback algorithm. It retrains till the generator comes to a place where the probabilistic outcome is what the discriminator is wanting. And that's how a generative discriminator framework comes. Now, with this inform and the transformer is learning the objective probability of each of these embedded vectors of these words. So you can understand that a large language model is a large scale framework which is doing the same thing. What I said is very short scale, but to a large scale, LLM is doing the same thing. AI models are not generatively learning patterns. AI models are either generative or they are discriminative. Your classification algorithms are discriminative. Your knife base is a generative model. So all of these are like sort of uh, catered to doing just one thing. That is the difference between your older deep learning, machine learning AI models and the newer transformers and LLM models, right? So even older reinforcement learning wasn't as pervasive as generative discrimination networks and transformers, right? Or with self-attention. So this is the like the simpler, if I want to say, the difference between the two.
There is
Does that answer your question?
a question. What are the mathematical tools
What are the mathematical tools for what?
needed to develop LLM?
Okay. Okay. So I would move you to buy a book from O'Reilly which says how to develop LLMs from scratch. A very simple small language models can be developed on your CPU. Um, will it be that good? No, because you do not, the infrastructure requirement for training is pretty high. It's extremely costly from a single user standpoint. Um, Not from DeepSeek standpoint, where they have done it in $6 million, but uh, even from that aspect, I would say to understand the mathematics of it, you will need to learn that book. It's a um, very in-depth book that tells you what steps need to be taken. Now, is it uh, is it a intelligent step to learn how to do that? Of course, if you want to do that, go ahead, do that. Like I myself do that, but the impact of it is low because it's a problem that is solved now. It's now at a place where all it needs is more data, more information to give a better outcome, and more cycles to give a better outcome. The process is at an optimal state. There will be minor changes here and there, which will give you a few more things. And you will see models like DeepSeek and OpenAI, they will introduce more parameters to get better outcome. So it's nothing that you're doing which is novel. It's just something that you're doing which is the logical next step. So your impact as a researcher or a scientist or an engineer in that path will definitely be low. What you should be more thinking towards is these are already present today. What can I build over it, which is catered to problem solving, which is catered to something that I am trying to solve, which has real life implications or which has real academic implications. Now, from an academic standpoint, if you really want to learn it, I would say there's a book from O'Reilly is Building LLM from Scratch in Python. This is exactly the name of the book. It's a bit costly. It comes at 8,000 rupees, but you can buy it. It's around 4 to 500 pages. They have given the code as well to create your first very simple LLM. Any other question?
Any other question? Participant, you can unmute and ask also. So one participant asked when our country is going to develop our own AI platform like DeepSeek.
Yeah, so from country standpoint or company standpoint, we have to understand that when you take a decision like that, you have to understand the impact of it. Now, DeepSeek, the country which has done DeepSeek, they are a focused government who can do that without the implications, the human implications of what doing that brings. They are sort of like, um, validation or authority there is much higher than our country, which is a democracy. So you have to understand training, or even at a low cost, training these models require a lot of natural resource. It requires a lot of water, it requires a lot of electricity, and it requires a lot of your um, coal burning and all that to support that model. In addition to buying those parts where you're going to host that training, the GPUs, the CPUs, and then cooling, the air conditioning. So all of that costs, if you think about it from a democratic standpoint, it will definitely take those resources away from some people and think about from a social standpoint in a country like India, where it can also impact. We have still people who don't have electricity in their homes. We still have people who don't have roads in their homes. So, as a government or a people, we have to think that is this a problem that is that important for me to solve, rather than the problem of the social problem that I'm facing today. I can, anyways, today the government is spending billions of dollars to support AI. Um, but there's always a ceiling to that, where the government or people in power and academics and consultants, they have to tell them that this is where we need to draw the line. Now, the country like DeepSeek, they don't have that amount of accountability, right? Because they are the form of government they follow. And the impact of that we do not know because it's not a very open media society. So, as intelligent engineers for tomorrow, it's sort of like a dilemma question, but it's something we need to think through before making that decision. Okay, we will build this model. So I'll have a counter question for that. We have the Param Shavak GPUs still in NIT Delhi. I'm hoping, Anurag sir, we still do have that, right? From CDAC. Hello. if you're saying you're still on mute. So I would say that if you have the Param
So
Shavak machines,
Dr. S. Naveen Kumar wanted to ask something. So please, you can unmute yourself and can ask. Typed, what you wanted to ask. The picture may not clarify if possible. Check it was. Which picture you are talking?
okay, so that's what I said. You can go to Google and search with this headline. The very first paper will have this image in the second or the third page. You can download that and look into it.
And is this which framework is best to work with agentic AI?
Right. I would say start off with Crew AI because that is easy and that's very easy to start out on. You will of course need a ChatGPT subscription like 2000 rupees per month. But yeah, I think if the college already have a subscription, you can use that as well. Other than that, Crew AI is extremely easy to work with. So you will, it's but from a power standpoint, I would say LangGraph or LangChain is much more powerful as a framework. Although full disclosure, it is very hard to learn. It has a lot of mathematical and graph and network concepts which you need to be clear on to be able to use it.
There is no. So now, thanks Devayan for your presentation and thanks for accepting our invitation.
Thank you. Thank you.
Pinky, you may conclude the session.
Okay, okay, sir. Thank you, sir. We sincerely appreciate Mr. Debayan Chakraborty for delivering such an insightful and engaging session. The way you explained the key concept, including what agents and how agents work, and the definition of task and planning, the essential components of AI, and future trends in AI agents. Um, it's commendable. Your session was not only informative but also highly valuable for all the participants. Thank you once again, sir, for sharing your expertise with us. So, with that, mm, we conclude another enriching session of our ATAL FDP on generative AI. I extend my heartfelt gratitude to our distinguished speakers, Dr. Krishna Kummamuru and Mr. Debayan Chakraborty, for their time, knowledge, and insightful discussion. A big thank to you, all the participants, for your active involvement and through provoking questions. Your engagement makes this event even more valuable. Join us tomorrow at 2 p.m. for the last session of this FDP, where we will dive even deeper into the fascinating world of AI and its advanced application. Until then, keep learning and see you soon. Thank you, everyone.
Thank you, everybody.
Thank you, sir. Thank
Okay,
you
ma'am.
so much.
Thanks. Participants, there are few instructions for tomorrow. Tomorrow presentations will start up at 2 p.m. I think all of you are aware with that, right? To 3:30, 3:30 to 5, 5 to 6:30. And 6:30 to 7, we will give you the
Valedictory
structure.
session.
6 to 6:30, we will have test and feedback session. Okay. So 6:30 to 7, we will give the instructions accordingly. How should you fill the feedback? How should you appear in the test? So that time will be 30 minutes. 30 minutes you have to complete the test and fill the feedback form. And after that, we will have half an hour valedictory session. And after doing all the formalities, you will able to get the certificates after qualifying the attendance criteria and the marks in the test. Okay, see you. Bye.
Sir, at what time the test will be there, sir?
Check the schedule. It is, I think, 6:30 to 7.
Okay.
Sir, in schedule it is only till 5 p.m. only, and there is no further schedule given in the day schedule.
Please check.
No, we
I think
have
you are missing.
3 session
You are
tomorrow.
missing
With
something.
that,
Please
we
check.
have some feedback session also.
You check the schedule. I think you are missing one page.
Yeah, it
The
is
schedule
mentioned
is
in our
up
schedule.
to
You may
7:30.
please check.
In schedule, nothing is mentioned. There is no exam.
Please reset.
Okay, so I am
So actually,
telling you,
actually in the schedule itself, it is clearly given, sir.
if you will check the schedule over the WhatsApp group we have shared, and
No,
at the
but on
ATAL
the
portal,
group, on group what message is circulated, there is no exam given there. Only two parameters were given. One is feedback and one to attend the classes.
see, we are telling, please and listen the instructions. I am telling you, after the 3 sessions, there will be an exam and feedback in half an hour, 6:30 to 7. Okay, and it will be happen tomorrow. So we will give the desired instruction. And for test and feedback, uh, it is also mentioned over the ATAL portal. Okay, so we will meet at tomorrow 2 p.m. Please remember the time. Okay.
Sir, everything is mentioned in the schedule which I've already
Yes,
sent
I
in the
know.
mail.
I know. Everything
Yeah,
is mentioned in the schedule,
yeah.
but
I
I
just
don't
read.
want to
I
say
just.
multiple times here.
Yeah, yeah.
Everything
You
is
have already
given.
shared number of things in the mail, and in the particular mail we have
Actually,
mentioned six
we
schedule.
are also
Yeah,
following the same schedule to see the things.
yeah. Everybody can please check the mail because in mail, the Shivang sir already sent the schedule day 6, so you can easily
See,
read
I
up
am
to
not repeating
2:30.
it again because until they will not see the schedule, they cannot understand what is mentioned there.
Yeah, exactly. Everyone, please check the mail, and in the mail, day 6 schedule. Though in the day 6 schedule, we have 2:30 to 3:30, and up to the you can easily see the schedule. Everything is mentioned in the schedule.
Yes, yes. Up to 7:30 there is a program. Valedictory session is
Yeah,
also
yeah,
mentioned.
yeah,
Please.
yeah. 6:30 to 7:30 is a, I guess, exam and feedback
So
session.
if you see the mail clearly at last, we sent a detailed mail with all the instructions and attachments. Two attachments are there: conference brochure with schedule and minute-to-minute program. Three things were there.
Yeah, sir. 2 to 3:30 is for the session second, and
Yes,
3:30 to 5 is
3:30 to
session
5,
12, and
5 to 6:30.
yeah,
Okay,
5 to 6:30 is 6 session 13, and then 6:30 to 7:30 is online
maybe,
test and feedback. Yeah.
yeah. Actually, who have seen this schedule, they are aware with that, no problem. And if you are not aware, even you are not aware, then I am telling you. So please note it down. If you have not seen, there is a no problem, but I am telling, so please note it down. You should be prepared for your test also. And there is a qualifying mark for test. I will tell you tomorrow. So you have to qualify the test. Then only you will be eligible for the certificates. And for attendance, 80% attendance is required. Okay. So same instructions was given on the first day also by the volunteers. Okay. Good night. Bye.
Sir, test will be MCQ based or it will be subjective?
We will give all the instructions by tomorrow. All things will be finished in half an hour. So you will have enough time. Okay.
Okay, sir. Thank you.
It is not like
Thank you
that
very much.
it is very big exam you are not able to complete in that time. So it is short quiz. You know?
Okay, sir. Thank you very much, sir.
Okay.
So shall we leave the meeting?
Yes,
Yeah, please,
participants,
all
you
of you
all
leave the meeting. So
leave.
once you all will leave, then only we can take the attendance because joining and leaving time will be there. So until you
Okay.
will not leave, your attendance will not be marked in the Excel file.
Okay, sir. Thank you.
So now you can leave early.
Sir, how many questions will be there, sir, for test?
See, whatever questions will be there, but you have to complete in
No. How many
20
questions
minutes
will be
only.
there, sir? Because 25
20 minutes
questions.
for test and 10
Okay.
minutes for filling the feedback. Okay.
Okay.
Okay.